All right, vibing for data science. Supercharge your next project with Agentic AI. So there's a good reason why you've been hearing all about AI and data science so far, right? In many ways, the world of data science is getting transformed in a way that it is not in many years, thanks to AI, right? If you look at the last 3-4 years, there's been a massive transformation in just what the data scientist is expected to do in their jobs. We'll talk about what AI is doing for them, but first of all, when you think about the world of data science, you've gone from data science being focused on just predictive forecasting, some time series forecasting, some contribution analysis, classification, regression. Of course, this is the bread and butter of data scientists, machine learning, classic machine learning, right? But now you have a whole bunch of new things that have been added to the data scientist's plate, right? You have agents and applications coming in. You have semantic search and building RAG applications, creating vector embeddings, working with multimodal data, actually creating content, augmented content generation for your marketing campaigns. So a data scientist is being called on to do a lot more than they were just 3-4 years ago, right? And a lot of these things involve using vector search, involve using AI, and so on. Unstructured data analysis is blowing up, right? And this is awesome because in a way, as Gartner says, data scientists are becoming AI engineers and your data analysts are transforming into data scientists. So everyone is kind of moving more towards AI-powered capabilities, right? And we're going to talk about this and talk about how AI can actually help data scientists do their work better. Now, before we do that, quick introduction. My name is Suda Srinivasan. I've been in tech for about 20 years, worn a lot of different hats, and worked at a lot of different companies. You should recognize roughly half of these because I've spent a lot of time at startups, all the way from 3-person companies to companies that went public, and worn a lot of different hats, right? Up and down the stack, worked in research, engineering, all the way to consulting. And at Google, I'm a product manager in the data analytics and AI team. So all things BigQuery, Vertex AI, thinking about how the role of data scientists is evolving, right? What is happening with data scientists and data analysts as they kind of come face to face with AI tools and technologies. So that is kind of what we are looking at today. So let's look at what AI is doing, right? AI is fundamentally unlocking a whole world of possibilities, right? It's expanding the horizon and expanding the art of the possible for data scientists in 3 main ways, okay? The first one is multimodal data. I think over the last 10-15 years, we've all been told to go and store whatever data we can because at some point it's going to be useful, right? So documents, images, videos, we've been putting all this data in data lakes with the expectation that it's going to be valuable. Data is the new oil kind of paradigm. And now finally, AI is allowing you to go and unlock this data at scale in a way that is very seamlessly integrated with your analytics and data science, okay? And we'll talk about what that looks like. But that is a huge thing. So now you're able to run queries which say, score the sentiment of customer reviews on a scale of 1 for very negative to 5 for overwhelmingly positive, and do this for the 1 million+ reviews that I have. So free text analysis and doing this in line with your analysis. As you're actually analyzing your data, you're able to go and convert unstructured data to structured data. Similarly, you can go and look at videos that are stored in your Google Cloud bucket, and you're able to automatically extract things like damage analysis and sentiment analysis from those videos in line with your analysis, right? That is massively powerful, and AI is able to do that for you. The second one, which I'm going to spend quite some time talking about today, is agents and AI assistants making the lives of data scientists and data engineers a lot easier, right? And this is something that has massive potential. I know that there are lots of conversations about what exactly AI can do, how far can it go. So when I talked to Amelia, she said that we had a mix of practitioners and executives here. So do people want to see a demo? I want to make sure that there is enough appetite for a demo because I'm going to put myself out there and do a live demo. I want to make sure that people are... All right, good. We are doing it. The third one is blending real-world knowledge with enterprise data. And this is awesome because so far, if you think about it, right, the real-world knowledge, which is, hey, Gemini, tell me which schools have high ratings, tell me what's happening in this world, is a separate world altogether from structured analysis, which is, extract the information about top schools that have XYZ, right? Scores, admission scores in different colleges, for example. You're able to merge these two in a very seamless way. And I'll talk about this as well in pretty soon, but you're able to run queries that actually run this join in real time. So you're able to say, extract all schools in these zip codes or these area codes, which also have a high rating in niche. And you're able to run a query in a single statement that combines this kind of real-world knowledge which Gemini knows with structured analysis that you're used to from SQL world, right? And doing that in a very blended way. And that is immensely powerful because it gives you new ways to think about solving problems. So very quickly, again, I'm not going to make this a product pitch more than actually showing you what you can do. But at a high level, when you think about what we offer at Google Cloud, there are 5 pillars that we offer in terms of capabilities for data scientists and AI engineers, right? First one, which is kind of where a lot of the data science journey starts, is a solid notebook experience, right? And I'll talk about what the solid notebook experience really means, but it's important that you have a place where you can go and run all your analysis, do all your model building, connect to your ML operations, connect to your data integration, everything from one place, right? You need a driver's seat. That's what the AI-powered notebook is all about. The second one, rich data foundation, is kind of core to what we do with BigQuery and all our databases, which is how do you provide a way to manage and use and activate multimodal data, structured, unstructured, images, blob storage, all of it in one place. How do you kind of bring it into the purview of a single data system? The third one is once you have the data in one place, how do you apply different engines, whether you want a massively scalable serverless SQL engine or a similarly massively scalable serverless Spark engine, all of it operating on the same data underneath. That is something that makes it very, very valuable because now, depending on whether you're a Spark shop or whether your problem needs SQL analysis, you have people who are very comfortable with SQL and want to do their analytics and data science in SQL, you're able to use both these engines on the same platform, right? And if you have a Python shop where you want to basically use data frames and do PySpark and Python analysis, you can do that as well on the same data without having to move things around. No more silos, no more stacks built for specific technologies. Then the fourth one is bringing AI to data. Now that you have all your data in one place and you have ways to transform that data, how do you build your models? How do you train your models? How do you evaluate your models? Manage the life cycle of your AI ML from a place where you don't have to go to a different system and manage things, right? And that is important. That is where Vertex AI, which is our AI solution, comes in. And Vertex AI is very closely tied to BigQuery, which allows you to build both predictive and generative use cases on your data in BigQuery without having to move things around. And the fifth one is once you've built, okay, you've got a notebook, you love it, you've got a model that you want to use, how do you deploy it to an endpoint? How do you manage experiments? How do you kind of maintain your model garden? All of these things, the ML ops, how do you kind of operationalize it? How do you detect drifts and anomalies so that your model kind of evolves the way you want it to and doesn't go adrift, right? So these are all things that we provide as an integrated end-to-end solution. And there are a lot of companies that I think there is a healthy amount of both skepticism and concern about, am I doing it right? Do I have enough governance that I can trust my data, that I know that my AI is not going to be biased? And I think these are all the right problems. The previous panel, they talked about it. And I think this is where a lot of companies are getting ahead of the problem and actually thinking about what they can do and how they can establish the right kind of data and AI foundation so that they can trust what comes out of the AI. What AI is going to do is amplify the problems that you have in your data. So governance has to be front and center. You have to think about governance and access management up front and then use AI appropriately. So we're going to focus on 2 pillars today, just given the time we have. I want to talk about notebooks, show you what the notebook experience looks like, and then we'll talk about how you can bring AI to data in BigQuery. Okay? Let's go in. So before I could do that, this is what our stack looks like. Everyone loves architectures. I'm not expecting you to read all the different boxes here. Think about the layers, right? Multimodal data foundation, governance front and center across your entire, whether you have data in BigQuery or your open lakehouse built on Iceberg, or you have your self-managed formats on Google Cloud Storage, you can manage governance for all of them using Dataplex in a very centralized way. Then you have all the different analytical engines, right? Whether you want to use BigQuery for SQL, you want to use Spark, or you want to bring your own open source engines and have it work on the same data. We provide the ability to do that, kind of plug and play there. AI, ML, lots of different options. We'll talk about that. And finally, on the notebook side, we have our first-party notebooks. We call them Colab notebooks, right? So Colab notebooks are available in both BigQuery and Vertex AI. That's the experience we're going to show you. But we also have support for managed, VS Code or managed Jupyter. So if you are a big Jupyter Lab fan and you want to have the Jupyter experience, go for it, right? We've got ways to connect Jupyter with BigQuery and Spark and everything that we offer so that you can basically use familiar tools while connecting to your data on Google Cloud, okay? And then finally, MLOps, all things model registry, experiments, pipelines, scheduling, all of that is done using ML operations layer, okay? And one of the things that I will briefly mention where we pride ourselves is the fact that our cloud was built to solve our problems first. As you know, Google has 10 to 15 businesses that are over 2 billion users. So a lot of the problems that companies are facing now in terms of scale on the infrastructure side, we hit first and we said we have to solve it. So a lot of the technologies that came out of that became the foundation for Google Cloud. Similarly, on the AI side, we've been building and open sourcing a lot of technologies for 10, 15 years now. And DeepMind is bringing out new models, which are kind of first-party models around things like time series forecasting, weather forecasting, and we make those models available to as well. So this is kind of where we kind of are at the forefront of both data and AI, which allows us to bring those cool technologies to you all. So let's talk about the notebooks. One of the biggest problems when it comes to the notebook experience today is you have a lot of different places that you have to go to do things, right? If you want to go write code in Python, you go to an IDE that allows you to do Python. If you want to do SQL, you go to a SQL editor, or you go to something like a dbeaver to go and write your SQL. Standalone BI tool that is doing dashboards. Now, how do you move data between these? It's a very clunky process, right? Even if you have integrations, it is slow and error prone, and a lot of the time that data scientists spend is spent in plumbing and stitching rather than on data science. And this is a huge problem, right? Because this is all friction in the process for data science. What data scientists want to be thinking about is, would XGBoost be the right model? Is my data kind of fitting correctly? Do I have how much root mean square error am I okay with? These are the things data scientists should be thinking about. Instead, they're thinking about how do I move data from one system to another. So this is where our AI first Colab notebooks in BigQuery come in. So these are essentially like your driver's seat, the place, the cockpit for your journey, right? Where you sit and you can basically it's a unified development environment for whether you want to use SQL, Python, Spark, everything in one place, integrated native visualizations, and a lot of AI to basically help you with code generation, code completion, error explanation, error fixing, visualization, so natural language to viz, all of that built in, okay? So this is basically where you would go. Over time, what we have been doing is bringing more and more things to the notebook experience so that you don't have to leave the notebook to go do anything. If you want to go and monitor your Spark jobs, it is basically like a button on the right side. You click it, you see the status of your Spark jobs. You can spin up Spark runtimes, manage everything from there. So this is basically where you can mix and match. If you want to do Python for some things, generate a data frame and then use it further for analysis for something else, you can mix and match, right, between Python, Spark, and SQL all in one. It's a truly multilingual notebook in that sense. The data science agent is something that we announced 2-3 months ago. Very cool stuff. It is basically, so Google's approach in this area has been to create a family of first-party data agents. So we have something called the data engineering agent, which helps with all your pipeline building, pipeline troubleshooting, and so on. We have the data science agent, which is basically going to take natural language and convert it into a multi-step data science plan. And I'll show you what that looks like. Run down the entire plan all along the way. You can kind of say, no, I don't want to do this, I want to do that. Think about the data science agent as an AI ML expert that is working with you, right? And it's very easy to forget that you're even talking to an agent and start having conversations. I've had chats like, does that root mean square error look okay to you, right? And it'll actually translate that and say, okay, here's what it looks like, and here's why it could be very high. Here's what you can do to fix it. So it becomes an iterative problem-solving process rather than you talking to an agent, right? So it's very cool in that sense, and we look at that. But this is where you can talk to your data and explore it. and understand it rather than having to do all the steps yourself. The data engineering agent is, think about it as a companion agent, because when I start talking about the notebook experience and say your journey starts here, I always have data scientists put up their hand and say, but what about data cleaning and data wrangling and all the mess around pipeline building? Who's going to do all that, right? That is where the data engineering agent comes in. The data engineering agent is able to take natural language prompts and convert that into data pipelines, like doing complex joins, building scheduled jobs that you can run to create your table for analysis, your feature tables. If something breaks, you can ask the data engineering agent to go figure out why it broke and fix it. And it does a lot of that in an automated way for you, right? So immensely powerful, especially if you are a data scientist who's spending a lot of time with data cleaning or spending cycles waiting for data to get to the state that you can start using it. The data engineering agent is built in and allows you to do this in a very seamless way. All right, demo time. And glasses time. Okay. So this is our notebook, okay? Very plain, very simple. I can basically collapse. It has a lot of navigation. This is our BigQuery notebook experience. I'm going to collapse this so I get a lot of space. And then I will take a prompt. So what can I help you build? Thank you for the very friendly prompt. Let's add this. I say, okay, I have this table it's a BigQuery public data set. It's called Austin Bike Share Rides table. I don't know the exact name, but go and extract 10 rows from that. I want to see what that table looks like, right? One of the first things you do is I want to understand the shape of the data. I want to see what I have. So what does the schema look like and so on. So let's run this. And what it then does is say, okay, this is a simple enough prompt. It is a pretty mundane activity. But what it does is go behind the scenes and figure out, okay, when I say Austin Bike Share, I hope the network is good. Okay. It says, here's the code to extract 10 rows from it. Figured out that I'm talking about BigQuery, public data, Austin bike share trips. Right? It'll also do this for data that is in Kaggle and so on. And then it gives me a query that I can use to go and extract those 10 rows. Right? So I say accept and run. I can always go in and edit it. And sometimes, by the way, the agent does make mistakes, but that's also where the automated error correction comes in. Right? It goes in and says, oh, I've made a mistake, let me go figure out what's going on and fix it. So after a couple of iterations, it actually comes out with code that works. So that's awesome. So I see that this table has, so this is basically like bike share. I don't know if you people have used like Lime or what is that, the Uber bike rentals, right, where you could actually rent a bike. So this data tells you what is the subscriber type, what is the bike ID, and what type of bike is it? Is it an electric bike? Is it a classic bike? When did the trip start? When did the trip end? Where did it start? Where did it end? Right? And what we want to do is use this data to basically figure out if I can forecast how many rides I'm going to get from each station so that I can think about my marketing campaigns better. So for that, I say, okay, this is great. Now let's use this other prompt where I get a little more involved, a little more serious about it. I say, okay, let's use, so first one, what it did was it loaded that data into what's called a data frame. You all know what data frames are. We all love data frames. They're so easy, so versatile, but they're running in the notebook's context. We offer something called BigQuery data frames, which are called big frames, which are essentially syntax compatible with data frames, but are essentially running on unlimited SQL in the back end, which is BigQuery, right? So BigQuery data frames are essentially data frames for you, but using the massive scale of BigQuery behind the scenes. So I want to switch to BigQuery data frames. Using big frames and the Austin bike share trips table, build me an Arima Plus model to forecast the daily demand. So I want to go station by station and say, I want to forecast the daily demand from a specific type of subscriber so that I can then figure out where I can see the highest predicted use and concentrate my marketing efforts there. Okay? Does the request make sense? Good. Let's. If it makes sense to us, hopefully the agent gets it too. All right. So it says happy to help, very eager. That's good. It gives me a step-by-step plan, right? It starts with data loading, load that data into a BigQuery data frame. Then it says data pre-processing, go and aggregate daily demand by station. So it does a group by to aggregate by station. Then it does model training on using Arima Plus, does forecasting, does analysis and prioritization of status of stations, and then finally gives me a beautiful report that says you should go prioritize these stations. I can go in and always say, don't use this, don't do that, modify the plan. That is my prerogative, right? And once I do that, it'll come back with an altered plan that tells me what it wants to do. So I say, this is good, go and create the code for this. And the best thing is, okay, while it's running, so it's basically saying, okay, first I want to go read it. It's switching to import big frames, which is the BigQuery data frames. And then it's going to read it and peek. Let's say accept and run. So if you look at it every time, it's prompting for user input, right? It's saying, are you good with this plan? Do you want to change anything? And if you don't want to change anything, then it just goes ahead and runs it for us, automated, right? And there, it's basically giving me what data is contained in that table. That looks good. And now what it's going to do is use this data that is extracted to go and build my next query, which is going to be the group by and preparing the data for AI. And as you are looking at this, so look at what it's doing. It's basically extracting, it's grouping by trip date and start station time, right? So that it's able to say, okay, what does my forecast look like? I want to forecast by each station. I want to look at what the forecast looks like. So I say, looks good, run it. And as you're seeing this, folks, just think about, this is fairly routine stuff, right? This is like classic predictive modeling. Think about how long it takes you if you had to start with a clean slate and build this by yourself, right? Okay, that looks good. It's just done a peek to say, okay, does the data look good? It looks great. And there are a bunch of stations where there are no trips, so that is fine too, right? Not all stations have trips. That is to be expected. Continue. And one of the cool ways that I've used this is, sometimes I don't know which exact model I want to use. I want it to tell me, like pick 3 different models, run it in parallel, come and tell me which model is best for the data that I have, right? And I love that, because if I were to do that by hand, that's going to be like pretty much like half a day spent just fine-tuning everything. So, okay, that looks good. It's going to be running Arima Plus on each of the different groups. And while it's running, the one secret I'll tell you is, I mean, some of this is not deterministic, right? It actually runs, it thinks each time. So pretty much every time I run it, there might be small variations. Like this. It's now found an error. I can either ask it to explain the error, or in the interest of time, I might switch. Keep running. Almost there. I don't know if you all are holding your breath like me, but wait for it. If it keeps running for another 30 seconds, I'm going to switch. Like a chef, I'm going to bring out the next step and pull up that tab. It's doing the right thing, but it's taking a long time. So All right, while it's doing that, what it's done here is already gone through all the training and built my daily demand forecast model. Right, now I can jump to the forecast step and say, accept this and run, if I have the runtime running. And okay, we will come back to this because it is going to run for a while. But one of the things that I did not plan for, but you saw, was it hit an error. And after it saw that error, what did it do? It went and tried to figure out what's going on here. It was using an outdated version of the library because some of that is just what it's trained on. It says, okay, let me go and see how to fix it. Automatically fixes it and goes to the next step, right? And so this is where an agent comes really handy, because some of these things, if you hit it, actually having to go and troubleshoot it and figure out what's going on is going to be a massive lift. So this is where, I've seen agents come in time and again, like 2 or 3 attempts, it figures out exactly what's going on and fixes it for you and saves you a lot of time. So we shall come back to what our friend is doing. And I will continue. Okay, so code generation, we looked at what it offers there. Error explanation and error fixing, we saw that in action. Prompt to visualization is something that I would love to show, but I think we are running out of time. But it actually allows you to take natural language prompt and convert it into a matplotlib kind of visualization, right? And easily create that within the notebook experience itself. And one of the things we are introducing is native visualizations built using Looker Studio within the notebook experience, so even richer visualizations. And finally, as I had mentioned, if you don't want to use Colab and you instead want to use Visual Studio Code or Jupyter extensions, you can do that because we've got connectors from BigQuery, Spark, Vertex AI, all the different Google services directly into your Jupyter Lab or VS Code extensions, right? And we've got, if you want to use Jupyter in a managed way without having to think about infrastructure, then we've got the Vertex AI Workbench, which is a managed hosted service built around Jupyter. So very quickly, right, just looking at what we have seen companies use agents for. What are agents good for? They are good for automating the mundane stuff. They're good for, hey, I want to go and import these libraries. I want to go install these libraries. I want to go and clean up this data, do this data transformation. All the stuff that you know how to do, but it takes time to go and do it. That's a great use for an agent. The second is scaling the possible. If I want to go and try 5 different models and figure out what's going on, scaling the possible is exactly what agents are built for, because they do a rinse repeat in a much better way than you would be able to. And finally, eliminating the cold start problem, right? One of the things that we've heard from our customers is it is good to not have to start with a clean blank slate and figure out what to do. Sometimes I want it to give me some code that I can start modifying and editing. It's just like when you're writing something, it's easier to modify and edit things than starting with a blank slate where you don't know where to start. Agents are great for that. They kind of get you to the start line much faster. And finally, moving faster, right? So things like troubleshooting, things like debugging, and even just coding, like basic coding, code completion, agents do a great job. What agents are not good for, they're not going to be replacing data scientists in your organization. So I think what it does is think about it like an exoskeleton, like a suit that you can wear that lets you get faster and stronger. Okay, that's what the agent is doing for you. It's working with you and essentially enabling you to move faster and do things that you were not able to do given the time constraints that you have. We have an ebook that actually covers a lot of the use cases. So if you're interested in actually going hands-on and trying things out with the data science technologies that Google offers, definitely go and check out the ebook. It's ungated for this audience, so definitely go check it out. I'm going to give you just 10 seconds. All right. So bringing AI to data, now that you have all your data in one place, how do you go and activate this data with AI? And we give you a lot of different ways to do this. The first one is BigQuery ML, right? So BigQuery ML allows you to basically build, train models, do feature engineering, everything using SQL from within BigQuery. right? So you can basically have models that are trained in Vertex. You can run inferencing in BigQuery. You can also build and train your models right within BigQuery itself. So that is one approach which allows you to bring your AI closer to BigQuery without ever having to move your data out. Second one is you can scale your model training using Spark. So we have a serverless Spark offering that is integrated into BigQuery. So from within your notebook, you can basically run Spark jobs to go and train your models, do everything that you want. So if you're a Spark shop and you already have a preferred pipeline for Spark, you can do that from within BigQuery notebooks itself. And the third one is you can manage the lifecycle of custom models. So if you have very specialized models because you have data sets that are highly proprietary and you want to do some custom model building, then you can do that whole lifecycle in Vertex AI and have those models be imported and used in BigQuery without having to move your data again, right? So this is where BigQuery and Vertex AI kind of work hand in hand very closely to give you that unified experience. Wide range of options, predictive, whether you want to do predictive modeling, generative AI, augmented analytics, or running remote models in Vertex AI, you have this broad range of options for you to explore. And that ebook actually gets into a lot of the details there. And finally, when it comes to frontier models, we give you direct access to models like models coming out of DeepMind. So we have something called Times FM, which is zero-shot time series forecasting. You don't have to train the data. You don't have to train any model on the data that you have. You're able to it's a pre-trained model available, a foundation model available from DeepMind that you can use for your inferencing, okay? As well as a broad range of models from other models from Gemini, as well as third-party models. So you can think of Vertex AI as a model garden where you can use first-party models, as well as models from Claude, Mistral, some of OpenAI's models. All of that is available for you to use within BigQuery with your data. Okay, so massively powerful because now you have everything in one place and you don't have to worry about whether the model that you want to use is there or not, right? And we also connect with Hugging Face, so if you have models from Hugging Face that you want to use, you can go right ahead. This is the zero-shot forecasting with Times FM, massively powerful and very useful for, if you want, this is one of the things that we've seen people do time and again, right? Just time series forecasting. And rather than having to build your own Arima Plus, you can use Times FM. So that's what I had. How are we doing on time? 10 minutes past. Oh, perfect. All right, I'll be outside if you have any questions. Thank you all.